Okay, in this example, we are looking again at a geometric series. We are actually asked to calculate the sum again, which means we're solving for S. Okay, so when we go to fill in our equation, we want to eventually end up using the equation Sn equals T1, 1 minus r to the power of n, all over 1 minus r. Right now, we can identify term 1 is -3. From there, we can also determine our r value by taking the second term, which is -15, divided by -3. Now, if you're asking why -15, well, remember that a series is always talking about a sum or adding. If we're subtracting, that means that the value of the term itself needed to be negative because we just wanted to add it together. Okay, so r is actually +5. Just negative divided by a negative is a positive. Okay, we're solving for Sn, but we actually don't know n either. So this is our main one, but we need to still figure out what n is first. So how are we going to do that? Well, we know the last term is -46,875. And so what we're going to do before we go ahead and actually solve for our sum is we need to figure out what n is. What is our last term? How many terms are included in the sum? So I'm going to have to go back to my other equation, which is Tn equals T1 r to the power of n minus 1, and we're going to have to solve for n. And if you don't remember how to do that, that's okay. What I would like you to do is I would like you to pause the video right now and try this on your own. So I would like to think that you've gotten to this point by yourself. This 9,375 equals 5 to the power of n minus 1. From here, if you're a little bit stuck, I'll give you a clue. We want to figure out how can I write this as 5 to the power of something. I want to be able to fill in that box so I can compare these two sides. How do I do that? Well, if you don't remember, okay, what we do is we take that 9,375, we're going to divide it by 5, and we're going to keep dividing by 5 until we get all the way to 1. We don't stop at 5 because 5 can still go into that evenly. We stop at 1. So pause the video again, use your calculator. How many times does 5 go evenly by multiplying into 9,375? So you're going to keep divide by 5, divide by 5, divide by 5 until you get all the way to 1. Now, if you are sitting there and you're like, Miss Conrad, that number is not right, I totally agree. Actually, I must have punched something in wrong in my calculator. This is 15,625, and that should work a lot better. So again, pause the video, figure out what should your exponent be. So I got that 5 went into 15,625 6 times evenly when I was dividing it repeatedly. Okay, which means that 6 needs to be n minus 1 because we need to match my exponents. So n must then be 7. Now that I know what n is, it's no longer an unknown. I know it. I know 7. I know r. I know my first term. Now I can solve for the sum of my series. So again, I'm going to plug and chug. And this time I don't need to move my formula around. So that's kind of nice. So I'm going to take -3 multiplied by 1 minus 5 to the power of 7, all divided by 1 minus 5. So I'm going to simplify this a little bit, and I get negative 78,124. I'm going to multiply that by -3 and then divide by -4, and so I'm going to end up with negative 58,593. So that is going to be the sum of my 7 terms.